Hello everyone. We're going to continue through section 7.3 with the learning objective, draw Lewis structures depicting the bonding in simple molecules. So let's go ahead and get started. Make sure you're comfortable with the concept of Lewis symbols that was in the previous video before watching this video where we talk about Lewis structures. So a Lewis structure is similar to a Lewis symbol, but it is for the entire molecule. So we are showing in a Lewis structure the valence electrons, and some of those valence electrons will be part of bonds, and some of them will not be part of bonds. We can show this in a couple of ways. So we're showing a chlorine molecule here, where we are showing each of the pairs of electrons. And you'll notice that we're showing this shared electrons that are shared between each of the atoms. That pair of electrons are the bonding pair. They are the electrons responsible for the bond between those atoms. The other electrons are what we call lone pairs. The lone pairs, the lone there doesn't mean that they're by themselves. It means they are connected to only one atom. So they are not shared between different atoms. They are a pair of electrons associated with only one of the atoms. We can share the bonding electrons. We can show that in a few ways. We can show it as we did here, as the two dots, or we can show it as a single line. A single line is representing two dots or two electrons that are being shared between two atoms. If we have exactly two electrons, we call that a single bond. As we have talked about in a few of the previous videos, when we draw Lewis structures, we want to satisfy the octet rule. So the octet rule is saying that we want to gain, share, or lose electrons such that we have valence electrons structure that resembles that of a noble gas. So for covalent bonds, how that works is that we count any electron that is shared as if it belonged to either one of the atoms that are sharing that electron. So we can see some examples down here of satisfying the octet rule. So in this molecule, for each of the chlorines, they have 6 lone pairs of electrons. They also have a single bond between the chlorine and the carbon. So the single bond counts as 2. Each of the lone pairs counts as 2. So we have 2, 4, 6, 8 electrons for that chlorine. Each one of these chlorines would have the same thing. For the central carbon atom, we have 2 for each bond. So we have 2, 4, 6, 8. So we have a total of 8 electrons to satisfy the octet rule on the carbon as well as on each of the chlorines. Here we see additional examples of molecules, and hopefully you can look at each of these and see how they would satisfy the octet rule in their own way by each of the atoms having those 8 electrons, specifically looking at the central atoms. There is somewhat of an exception on many of these, and that is the hydrogen. The hydrogen only needs to have 2 electrons to resemble a noble gas. So when you have hydrogen as part of a molecule, it will almost always be found as only a single bond to the hydrogen and no additional electrons. Because if hydrogen gets 2 electrons, it would resemble helium. So it is still resembling a noble gas. Some sources would call that the duet rule. It's essentially the same thing as the octet rule in that you are satisfying being isoelectronic with a noble gas. It is possible to have what are called double or triple bonds. When this is occurring, what happens is that you are sharing more than just 2 electrons between atoms You could be sharing 4 or you could be sharing 6. So some good examples of where we might see double bonds, we have formaldehyde here, and we're showing 4 electrons that are between the oxygen and the carbon, and we can do it in this way, or we can do it in this way where we're showing 2 lines. Essentially 4 dots equals 2 lines, which is consistent with basically every line represents 2 dots. And we can double check here that this is satisfying the octet rule. For the carbon, we have 2, 4, 6, 8 electrons. For the oxygen, we have 2, 4, 6, 8. Okay, so that's still working. The octet rule is still working there. Here we're showing some examples of triple bonds. So here we're showing carbon monoxide. In a triple bond, we have 3 electrons being shared between the 2 atoms. We have, in a triple bond, we have 6 electrons being shared between the 2 atoms. So we're showing that here, or we can show it as 3 lines. Again, each of the 3 lines representing 2 electrons. So we have for the carbon 2, 4, 6, 8 electrons. For the oxygen, we have 2, 4, 6, 8 electrons. So as you can see, the Lewis structure concept is very much dependent on applying the octet rule. Here we're showing some simple, fairly simple molecules where we are showing how we can take the Lewis symbols of the elements that make up those molecules and then arrive at the Lewis structures for the molecules that they form. And here we have an example, another example of a triple bond. I want you to kind of make sure you're comfortable with the general idea of a Lewis structure. So maybe watch this and do some examples. We'll be moving forward with more complicated examples here in a minute by going through a step-by-step procedure. So we'll stop here and continue in the next video.